Hello everyone. So today we are going to learn about proportional integral or PI controller. So whenever you are designing a control system, you always have some design goals or objectives, and if it includes the elimination of steady state error and to improve the stability, along with it to improve this transient response as well, then the suitable controller for your need will be proportional integral controller or PI controller, which is one of the most widely used controller in industries. Now, to understand why is it so, we will understand this controller in detail. Now, as by the name suggested, the PI controller is a combination of two types of controllers. That means the proportional controller and the other integral controller. So for the case of proportional controller, the main advantages include its simple construction, along with its ability to make the system really stable and also improve the speed of response. But have this disadvantage of having a constant steady state or offset error. It also increases the maximum peak overshoot. Now for the case of integral controller, let us learn about it. They reduces the steady state or the offset error occurring in the proportional controller and have this special ability of returning the system to their exact point, and it is for this reason they are also called as reset controllers. However, have a disadvantage of making the system really unstable as this respond really slow towards the produced error. So here's the output for the proportional controller, where the output is directly proportional to the error produced by the difference in the actuating signal and the defined set point. And for the case of integral controller, the output is proportional to the integration of the errors. So the integration of the error over the time means that we sum up the complete controller history up to the present time, starting from when the controller was first switched on to automatic. When the two types of controllers are joined into a single one, a new type of controller is formed, which is PI controller, whose output UT can be defined as in the figure. So this new controller is not just a combination of the two output, but also a combination of these two controllers' properties as well. So in order to understand the properties of PI controller, let's take the Laplace transform of the above transfer function. And we get the following output defined in this figure as US. So as you can see, there is a pole at the origin and a zero at somewhere away from the origin, but in the left hand side of the S-plane. Now because of this pole at the origin, this have a serious effect on the stability. The stability will be reduced. Also because of the integral term, the response of the system will become sluggish, and hence this PI controller can be used where in the system the speed of the response is not a bigger issue. So one of the best advantage of PI controller is completely reduces or eliminates the steady state error, which is the biggest disadvantage of the proportional controller. So the desired output can be achieved very accurately. The PI controller in practical is very easy to be implemented and hence so don't have really high cost. And hence they have a lot of applications in the speed control of the motors or generator or in turbine. Also used in liquid